Extrema, relative, absolute. All right, so we've been talking about that. Now we're going to go look at how to use our calculator to approximate extrema. And this is corresponds to example 3, which is on the bottom of page 37 in your textbook. And we're going to first look at what we're being asked to do here, and then we're going to jump to the calculator so that we can use our calculator to approximate extrema. So here in example 3, it says approximate to the nearest hundredth the relative or absolute extrema of each function. State the x values where they occur. And so we've got two function equations here that we're going to deal with. The first one is h of x is equal to 7 minus 5x minus 6x squared. And I'm going to rewrite that when I enter that to be this. I'm going to rewrite this as negative. That should be a negative 6x squared minus 5x plus 7, just because I like to, or rather have that in standard form. And then the second equation we're going to look at is g of x equals 2x cubed minus 4x squared minus x plus 5. So keep those in mind. Get on page 37 so that you've got these equations in front of you, and we're going to move to the calculator and demonstrate how we can use our calculator to approximate extrema. All right, so here I'm over on the calculator, and I have entered the function equation for example 3a, and as I did on the previous slide, I rewrote that to be negative 6x squared minus 5x plus 7. And then when I go to my graph, here's the graph of this function. Now I can see from my end behavior that both of my end behavior, left and right, is going towards negative infinity, f of x, or in this case, h of x. But I do see an extrema here, right here where my cursor is, and it's going to be an absolute maximum because everything else is headed down. Now, in order to approximate what this point of extrema is, I can go to second calc, and you see here under the calculate function, I got a minimum and maximum. Well, I know I'm doing a maximum here, so I'm going to enter 4. And now I got a little blinking cursor. So what I want to do, and down here at the bottom you can see left bound, it's got a question mark. Well, I want to move this cursor to where maybe it is just to the left of where I see that maximum, and it's saying left bound, and I'm going to hit enter. And then it's asking me for the right bound, and so I'm going to move it maybe just to the right of where I think that maximum is, and I'm going to hit enter. And now you see it says guess. And so it's going to guess at this extrema. And I'm going to say I'm going to hit enter for that. Okay, so then it says that it looks like we've got a maximum, again, an absolute maximum, if you're looking down here, down this way here, where x is equal to negative, and it's asking us to the nearest hundredth, if you recall. Approximate to the nearest hundredth. So x is then negative 0.42, and at that point y would equal to the nearest hundredth 8.04. And there we go. We've used our calculator to approximate, in this case, the absolute maximum extrema. And we'll look at the second example here shortly. All right, well, let's do the second example. I'm going here to y equal. I'm going to clear out this first equation, and I'm going to enter the second equation where it's g of x is equal to 2x cubed minus 4x squared minus x plus 5. And so let's see, we got 2x caret 3, move the cursor, minus 4x squared minus x plus 5. So let's check the graph of this thing. So here it goes. Okay, well, let's see. My end behavior here on the left is going to negative infinity. My end behavior here on the right is going to positive infinity. I do see a couple of points of extrema, but they are going to be relative. So in other words, this is a relative maximum because my maximum continues on out here to positive infinity. And this is going to be a relative minimum because I can see my end behavior going all the way down here into negative infinity. So I want to get the extrema at these 2 points right here. All right, so I'm going to go second trace or calc, second calc. And since the first thing I saw was a relative maximum, I'm going to choose 4 again. And again, I'm going to move the cursor just to the left of where I think that maximum occurs. And down here it's saying left bound. I'm going to say, yeah, left bound. And then I'm going to move the cursor just to the right. Right bound, yes. You want to take a guess on this? Yeah, sure I do. Okay, so that's telling me then it looks like I've got a relative maximum where x equals, and again, we're doing it to the nearest hundredth, negative 0.12. And at that point, y is equal to, rounding to the nearest hundredth, 5.06. Okay, not bad. Now, let's do to the minimum. I'm going to go again, second trace for calc. This time I'm wanting to do the relative minimum, so I'm going to choose option 3. And I've got to move this cursor down here. And again, I want to get just to the left. Yeah, let me come back. That looks like it's just to the left. Seeing the left bound? Okay, yeah, left bound. Give me that. Then I'm going to go just to the right. Do a couple of clicks here. Right bound, yes. And do I want to take a guess? Well, sure, why not? Okay, and so this is indicating then that we've got a relative minimum where x is equal to 1.45. I'm rounding it to the nearest hundredth. And at that point, at that x value, y then is equal to approximately 1.24. All right, there we go. Using a calculator to approximate extrema, in this case, the second example was both a relative maximum and a relative minimum. I tell you what, you can't get much more fun than this. Shazam.